Welcome everyone. This is going to be a webinar talking about managing your data warehouse incremental loads using SQL Server Change Tracking. So our agenda, we'll briefly talk about the need for doing change detection and change tracking in data warehousing, why we do change detection at all. We'll talk about specifically the SQL Server pieces, the change tracking elements that we'll be talking about. And I'll talk about how to blend those two together. So the mechanics of how you would use change tracking and how that applies to a SQL Server load and a data warehouse load in the SQL Server realm. Some of you know me, some of you probably don't. My name is Tim Mitchell. I'm a data warehouse and ETL architect. I run a company called Tyler's Data Solutions, and I provide solutions around what we're talking about. So data warehousing, ETL, some reporting, some analytics as well. I've been a data platform MVP for the last 6.5, coming up on 7 years now. If you want to follow along, I blog and I have some commentary at timmitchell.net. If you want to follow me on Twitter, it's Tim_Mitchell. I also have a semi-weekly newsletter that I publish every 2 weeks, timmitchell.net/newsletter. I'd be glad for you to take part in that. I do a lot of announcements there. Talk about upcoming training classes and things like that. So if you want to keep track of me, that's probably the best way to keep abreast of what's coming down the pike as far as I'm concerned. All right, so at a high level, let's talk a little bit about data warehouse and just the concept in general. Why do we need change detection at all? The biggest thing that we address in change detection is the need for good performance. So back in the day, back when we had tens or hundreds of thousands, maybe a million rows of data, it probably wasn't as big an issue. Nowadays, when I ask about what's your biggest ETL load in a data warehouse scenario, very often it's billions, several billion. I've heard hundreds of billions of rows, and just in terms of gigabytes, there's really there's no limit to that. Gigabytes, it could be even into terabytes or in some cases petabytes. The reason we do change detection as far as performance goes is the less data we touch, the less data we have to process through our pipeline. So if you touch fewer rows, it's simple math. If you touch fewer rows, it's going to cost you less in terms of performance. But from a data warehouse perspective, maybe even a bigger issue than that is the fact that on an incremental load, you're retaining your historical record. So think about something like this. So you've got a person who lived in Florida, for example. They moved to Minnesota, and then they moved down here to Texas, where I'm from. Let's say while they lived in Minnesota, they had some event, so you're an insurer, they had some event related to their account where they had a snow-related crash. They had, say, 3 snow-related claims in the matter of a few years. Now, if you looked at their historical record, rather if you look at their current record, if they moved from Minnesota down to Texas, you would only see that this person's had a number of snow-related or ice-related claims over the last few years, but they live in Texas, so that really doesn't coincide with what we expect in terms of weather phenomenon. What you get if you retain that historical record is I can see that even though John Smith now lives in Texas, when he filed those snow-related claims, he actually lived in Minnesota. So it makes more sense to retain that historical record and know not just where he lives right now, but what those aspects were whenever that event occurred. So the fact that he used to live in Florida, he moved to Minnesota, had some snow-related claims, and then he moved to Texas, that's an important piece of information. Not everything is critical to encapsulate in change detection. For example, if his hair went from blue to gray, that's probably not a sentinel event. It's not something that we'd necessarily care about. But something that changed significantly, like his address, that's something that we probably want to have a historical record for. So those two aspects are really the biggest factors in why we need to do change detection in the first place. Touching fewer records so our load performs well, and then just from a fidelity standpoint, looking at the historical record and maintaining that history over time. Ideally, if you can detect the changes at the source, so whatever the source might be for you, this might be an OLTP database system, maybe it's even a series of flat files or whatever that looks like to you. If you can implement that change detection on the source side, it's going to cost you less in terms of performance because, again, you're pulling fewer rows of data into your ETL pipeline. So the fewer rows of data you touch, the less time it's going to take to process that load. There are a couple of different ways that you can manage that. The update timestamp is one of the more common ones that I see. It's also one of my least favorite. The update timestamp, you've probably all seen it in a load. where every row identifies a timestamp when it was either loaded or last updated. Assuming that's a correct piece of information, that's actually a good identifier. And in my experience, that's not a reliable piece of information because that assumes that any piece that touches that ETL processor, that touches that row of data, abides by the rule of you have to update the insert timestamp or the update timestamp whenever you manipulate that row of data. If you as the ETL developer, as the ETL professional, are in complete control of that source data, maybe, just maybe, that's a true assumption. But in most cases, that's not the way it is. So while the update timestamp, assuming it's reliable, it can be used. In my experience, it's not a reliable marker of information. What that looks like is like you see on your screen here, where I've got my transaction time when it was actually the transaction occurred in real life. And then I've got the row timestamp separately that shows when was this loaded into the system. So again, we can easily filter on that, but in many cases, that's not a reliable piece of information. If that's the only thing that you have, obviously you have to use that, but it's not my favorite. Another piece is change data capture. So this is a little more heavyweight piece. It's still on the source side, where you set this up on wherever you're storing the data. This has to be a SQL Server. I won't say it has to be SQL Server. When we talk about change data capture from a SQL Server perspective, it has to be a SQL Server database. There are other relational databases that support CDC. Oracle has some flavor of it. I suspect DB2 and some other vendors probably have something similar. But in the SQL Server realm, the way this works is you set up change data capture on the database. You set it up on the table or tables that you want to monitor. And then it creates a full history of the entire update or the entire history of that record. So if you insert it, if you update it 14 times and then you delete it within a time span, change data capture will report that entire history. It will show you it was inserted here. The record, the first name went from Tim to Timothy. The address went from 123 Main Street to whatever else on Elm Street, and then it was subsequently deleted. Change data capture will tell you all that information, and it is useful for that type of reporting. As I mentioned at the outset, I'm more of a data warehouse person, so I don't typically deal with auditing to this level as much as I deal with the need for change detection. Change data capture, make no mistake, it's not just a change detection piece. It's actually a full audit. It has full audit capability, and will show you for this record everything that touched it, every process that touched it, the effective change and what the before and after results, were on that. If you need that, it's a very handy tool. Couple of downsides for that. It is a bit heavier than some of the other methods that I'll talk about, specifically change tracking. It's certainly heavier than that. It's asynchronous in that it relies on SQL Server agent jobs. And here's the biggest holdback. It does require enterprise edition of SQL Server. You can't use standard edition. You can't use any other edition if you're going to use change data capture. So if you need full data auditing capability, this is certainly a good way to go. But if all you need is change detection, tell me what rows have changed and what was that effective. Was it an insert? Was it an update? Was it a delete? CDC might be a little heavy for you, but again, this is a good option and one of several that you have available to you in SQL Server. Change tracking this is the thing that we came to talk about. This is by far, if you have control of the source, this is my favorite way to do change detection in SQL Server, specifically around data warehouse loads, but it works for a lot of other loads as well. So it gives you like I noted on the slide, this is delta detection. So if I insert a row, if I update it 14 times, then I delete it in between two load cycles, it's not going to show me the full history of what that row was after the insert, after change 1, after change 2. It doesn't track that level. What it will tell me is on a row-by-row basis, which of those rows has been inserted, updated, or deleted since the last operation, and basically it focuses on the net operation. So if I insert it, I update it 4 times, it'll show me this was an updated record because the net operation is that it was an update. This is a fully synchronous operation. Unlike change data capture, this is, I hate to use the word trigger-based because it's not a SQL Server trigger, but under the covers, it's a trigger-like mechanism where if you make a change to the tracked table, it will automatically bubble up and show you in your change tracking tables. It will automatically show that. There is no delay. It is a fully synchronous operation as that insert, update, or delete takes place. So that's a high level on change tracking. I do want you to be aware of a couple of other methods. If you don't have control over the source, row hashing can be a good way to do change detection. So effectively, this works assuming that you don't know from the source query side what rows are new, what rows are changed, and what rows have been deleted. So this will take a number of columns, all the columns that you want to track with respect to your load, creates a hash out of those, and I believe I've got a graphic that will show. Yeah. It effectively creates a binary value out of all those columns that you care about, all those columns that you want to track. And then that binary value, not the individual columns, are what you'll compare in your source and your destination to see, is this new, is it changed, or has it been deleted? So if you're doing a brute force, I call this a brute force, where I'm comparing all the rows in the source to all the rows in the destination. If you're doing a brute force, this is probably the most effective way to do that, because I don't know if you'll be able to see my mouse when I do this, in creating that binary hash, that comparison of a binary value will in most cases be much faster than doing a column by column comparison on mixed data types, and this is an int, and this is a date, and this is this and that. This will be a much faster operation. You do have to calculate that hash, but in most cases the calculation of the hash and then doing that binary comparison is cheaper than doing a column by column comparison any other way. And then lastly is just pure brute force. So comparing first name to first name, last name to last name. This is the least efficient way to manage change or manage change detection. It also comes along with the fewest assumptions. So if you're dealing with, say, text data, for whatever reason you don't have the resources or you can't calculate a binary hash, this is an effective way to do it. One of my least favorite ways to do it, but doing simply a column by column comparison is an effective way to manage change detection. So some of the tools, plain old T-SQL. Everything that I show you today will be just plain old T-SQL. I will show you an example of the T-SQL merge statement as well. Most of you, if you follow along with me, you know I'm a big SSIS guy, but I'm also a guy who likes the right tool for the right job. So you'll see me do a lot in T-SQL, specifically around the merge statement. If you're doing a slowly changing load, far and away the merge statement is the way to go. SSI is slowly changing dimension wizard. I hate to beat up on this tool too much, but I'm not a fan of the slowly changing dimension wizard and integration services. It's an effective way to do very, very small loads. And what I mean by that is if you've got hundreds or maybe a few thousand records that are changing over time, if you want a very wizard-driven approach, this can work. It does not scale. The slowly changing dimension wizard and integration services simply will not scale well. So my recommendation is, unless you really have to do that or there's some compelling reason that you need to do that, stick with one of the other mainstream tools like T-SQL or the plain old data flow components and integration services. You can fairly easily use those data flow components and do lookup transformations, maybe even conditional splits, and manage that load and make that, instead of a row-by-row operation, make that a set-based operation. A set-based operation will almost always perform better than a row-by-row. So if you're using integration services, my recommendation, if you're not using T-SQL merge, go ahead and use the data flow, but don't use the slowly changing dimension wizard because it will not scale. If you're doing more than a few thousand records, I promise you're going to feel a performance impact on that. Lots of third-party tools that also manage this. Too many to mention here, some free, some paid, but there are some third-party tools that will do something similar in either SQL Server or integration services. So specifically around data warehousing, so we have to look at, when we do change detection, is it a fact or is it a dimension? How are we processing that? Most of the time, if you're processing a data warehouse, the fact data will be just a straight load. The dimensional data will be some form of incremental or some form of change detection. So if it's already there, I want to update it. So the example that I gave earlier was the gentleman moved from one state to another state. In most cases, you don't want to simply insert a new record. You want to either update the existing record or possibly expire the existing record and create a new superseding record in its place. So change detection is necessary for both facts and dimensions in most cases because I need to know what's changed, what's different, and so on. But for the most part, your change history, retaining that change history, is typically reserved for dimensions. I have done a few slowly changing fact tables before. I prefer not to, just for a lot of reasons, performance among them. But in most cases, this is the design. You'll do a straight insert, a dimensional, or not a dimensional, an incremental insert on your fact records. And typically you'll do some sort of slowly changing either type 1, type 2, or something beyond that for your dimensional data, such as person information and whatnot. Step out of the data warehouse realm for a minute. Let's talk about the nuts and bolts of change tracking in SQL Server. It was brand new to SQL Server 2008. Here's a big selling point for it. It doesn't require any special edition of SQL Server. If you're using Enterprise, it works. If you're using Standard, it works. Even if you're using the free, I think it's called the Express version or whatever they're calling it these days. The free version of SQL Server also supports change tracking. So that's a big selling point. It does not require the most expensive version of SQL Server. You enable it on the database itself. So if you're using 10 different databases that you want to have for change tracking, you have to enable each database. And then after you enable the database, it doesn't automatically include all the tables. You have to go table by table and add those to change tracking. Now, that might sound cumbersome, but you're not going to have change tracking on every table. In most cases, it's going to be the ones that you're looking at specifically on the data warehousing side. It's only going to be the ones that you're loading from OLTP over into your data warehouse. So that's, even though that might sound cumbersome where you have to touch every table, that's actually by design because you wouldn't want to arbitrarily add all the tables to change tracking because that might be, that might add too much processing overhead that you really don't need to do. So I mentioned you turn it on table by table. You do have to pay attention to the retention policy. So those records, that change record is only kept for a finite amount of time. I believe the default is 2 days that it's kept. So keep in mind what your load cycle is when you're setting up that retention. Most of the time I set that beyond a couple of days for a couple of reasons. First of all, it's a fairly lightweight operation unless you have a huge velocity of changes in your track table. It's not going to bring down your table if you're doing a reasonable amount of updates. But also, if you leave it on the default, which is 2 days, think about, so let's say you're doing a daily load, for example. You come up on a long weekend. You've got a 3-day weekend that comes up. Something happens where your load fails on Friday, Saturday, and Sunday. You're now outside the scope of that retention period. So it doesn't necessarily invalidate the data that you've got, but what you would have to do is instead of relying on change tracking, if you fall outside that, you've got to go back and do a full load as opposed to doing your change detection or rely on something else like the merge statement using the brute force or using the hashing method. So do pay attention to what your load cycle is, what you're expected if something goes wrong, what the expectation would be for that. My recommendation is if you're doing a daily load, set that up to something beyond 2 days, maybe 3 or 4 or 5 days, just to make sure that if something were to happen over a long weekend or you're out on vacation, that you wouldn't lose all that history in your change tracking data. So the technical information that it brings in, it will track all your inserts, updates, and deletes, and it identifies them as such. You can say, show me all the records that were updated since the last version ID. It will let you track on a column-by-column basis. So you can interrogate and say, not just was this row changed, but tell me the columns individually. Was this column changed? Was that column changed? You can track that level of information. I'm not going to spend a lot of time covering that piece because from a data warehouse perspective, typically we don't really care about which columns were changed. The only thing we care about is this row, if it already exists, is this row different from the version that we already have in our data warehouse? And if the answer is yes, I want to go ahead and either do an incremental load or an update or expire the old version or whatever that mechanism looks like. I don't necessarily care did this column change or that column change. If it's part of the track columns, I want to trigger that event that will load that new record in. So some of the technical assumptions, and these you'll have to pay close attention to these. You do have to make a metadata change on your tracked table. So if you're an ETL professional, this might not be something that you already have access to. So if you're in, especially a larger organization, will probably have a whole different group of people that manage that level of security. So if you're just on the ETL side, you might have a whole different group of DBAs or support people who manage those permissions. So you may have to involve someone else in turning this on. Another technical assumption, the table that you're tracking, any table that you're tracking has to have a primary key. Now, in a perfect world, all your tables have primary keys anyway, but I've seen some of your tables and a lot of them don't. So you have to have a primary key on there. It's okay if it's a multi-column primary key. That's no big deal, as long as it does have a primary key on the table. Also, you have to have some mechanism for storing the last synchronized version. And by that, what I mean is every change that's tracked is not necessarily date stamp based, but it's version based. So you've got a big int value, and we'll look at it once we get into the demos. You've got a big int value that will determine or will let you know since the last version number 1, 2, 3, 4, whatever that version number is, these are all the changes that were processed. You're going to have to store that version number somewhere in your ETL infrastructure. It might be in your somewhere on the server running integration services or the one running SQL Server Agent or whatever is driving your jobs. But the bottom line is you need to store that. You'll have to store that somewhere because that's your marker. Think of it as a bookmark. This is the last time we did the load. Next time I run the load, the ending point for this load will be the beginning point for the next load. Some of the common functions around change tracking, there's really 3 that we'll focus on, and really I'm going to show you on the demos. I'm going to only focus on the first 2. Change tracking current version. You're going to use this a lot if you're using change tracking. This retrieves from the database what that current big int value is. So this is a database-wide setting. It's not table-specific, meaning that if I've got 5 different tables that are engaged with SQL Server Change Tracking, that value will increment not once per, not individually per table, but it increments database-wide. So every time I make an update to any table, that current version will update. So this is the function that you'll use to determine where we are in terms of the versioning, and that will set your beginning and end points for that load. Second function that you'll use is the change table function. Change table will retrieve from the named table or for the named table, and it only does a table at a time, all the records that have been inserted, updated, or deleted since the last version number. And the version number is a parameter to that function that you'll specify. So if my last version, if I run the change tracking load and I set, remember that table that I told you, you have to maintain that, that ID or that identifier for the last load. If the last one was 7834, I'm going to store that in my table. The next time I run my load, I'm going to grab everything forward of that, and that's the value that I'll pass into the change table function and say, give me all the inserts, updates, and deletes that are forward of 7834. I'll set my ending point for that load. That ending point for this load will now be the starting point for the next load, and we'll just leapfrog every time we do that. The last piece on there that, again, we won't cover this, but I do want you to be aware of it, is change tracking is column and mask. It's kind of a lengthy function name that you interrogate your change tracking table and say, for this table, was for row whatever, for primary key whatever, was this particular column updated, yes or no? And that will let you interrogate on a column by column basis to see which columns have been updated. Again, for data warehouse loads, probably not a huge consideration, but it's something you want to keep in your hip pocket in case you ever need that in the future. So a couple of considerations for data warehouse workloads. Typically, you're doing a batch load. Most of the time, it doesn't occur in real time, so consider that whenever you're structuring your ETL process. I'll show you how that works whenever we start doing the demos. Typically, what that means is that we're going to have a fixed point. We're going to have a finite start point and a finite end point. We're only loading everything between those endpoints. The reason for that is if I've got a high velocity change table and I say, okay, I'm going to run my ETL process, give me all the updates since version 7834. And as I'm running that update, I'm still getting, or as I'm running that ETL process, the OLTP table is still getting inserts, updates, and deletes. So I could have some crossover where some insert, update, or delete takes place, and either I don't track it, either it falls out, or inadvertently I end up doing it twice. So you want to make sure and set those endpoints, the beginning and end points, and I'll walk you through on how to do that once we get to the demos. In terms of data warehousing, this moves the typical change detection from the transformation step all the way back to the extraction step. This is a good thing because that means you're pulling in less data. You're not pulling in your entire set of data, your entire people history table, your entire location history, or whatever the table is that you're tracking. You're only getting those pieces specific to the load that you're doing. More options for handling slowly changing dimensions. As I mentioned earlier, there are several options that you can do in integration services and T-SQL. It is a good way, it is an effective way to manage that if you're doing the data warehouse workloads. To use SSIS, to use even the slowly changing dimension wizard. As I mentioned, that's not really my favorite. But here's where you stand on that. if you're doing it on change tracking, if you're using change tracking, it does present some more options for you on only pulling in the data that might have changed or might have been deleted since then. And furthermore, those rows that you do pull in, you don't have to interrogate and compare them source to destination and see what's new, what's changed, what's been deleted. You can instantly tell based on the query that you pull back from change tracking, this was an insert, it was an update or a delete. So it takes some of the burden off the T step in the ETL process and puts it back on the E step or the extraction process. Before I show you the queries, let me walk you through what this looks like on the UI side of things. Now, most of you, you're probably like me, you prefer to do things on scripting rather than the UI. So I'll show you what the UI looks like, then we'll kind of walk through what the scripting side of things would look like on this. On my change tracking database, so this is the one that we'll be focusing on, I'm going to right click on that database. I'm going to go down to database properties all the way at the bottom. And then if I look at, you'll see that I've got change tracking as about the 5th item down here. This is where we can enable or disable change tracking at the database level. You can see that I've already got that turned on by default. Keep this in mind. By default, change tracking will be turned off on your database. I've got this, I've overridden this, I've set that to be true, so we have turned on change tracking. I've also overridden that retention period to be 14 days. As I mentioned at the outset, the default setting is 2 days. I like to bump that up, storage permitting, I like to bump that up and make sure that we've got plenty of room to have all the changes that we might need to go back. So if I need to go back and do another historical load, for example, or we have a long weekend and things fail over the weekend, that 14-day buffer gives me plenty of time to go back and pull the history that I need. Days is the default, so I could set that to something less. I think I could even, I know I can go down to minutes. I think we can go down to hours as well. I think it'd be an unusual situation to do anything less than days, but the option is there if you need it. And then I do want to leave auto cleanup set to true. Honestly, I've never set that to false. What I suspect is that it wouldn't do the cleanup operation. Probably not what you want, because that change tracking, under the covers, that change tracking data would continue to grow and grow if you didn't turn on auto cleanup. So that's on the database side. Now we still need to drill in. Let me drill in just a bit here, go into my table. So individually, once we turn it on the database level, I also have to do it on the table level. So right click on the table, go down to properties, we'll go to change tracking, and I've really only got 2 settings to establish here. Change tracking set to either true or false, and then track columns updated. In this case, it's set to true. I have turned on the column mats, or that third function that I mentioned earlier that will let us detect which columns were changed, which ones are the same, and so on. I went ahead and enabled that. Again, with data warehouse loads, it's probably not a critical step, but it is there if you need it. Now, this is all scriptable operations. I'm more of a script person than a UI person. So with turning it on at the database level or turning it on at the table level, that's a scriptable operation. So that it didn't make any change, it's going to tell me that there's nothing to be scripted. If I go back to my initial reset scripts, the pieces that we just did should be in here. So I'm going to come back to that change tracking table. I'm going to go ahead and go down to this piece. So this is the first step that I showed you previously, where you go into the database properties and you look at change tracking. In this case, we're setting change tracking, turning it on, and then setting the retention period for 14 days. This is an optional setting, and again, if I didn't specify that, it would revert to the 2-day default. But this is simply turning it on. To interrogate whether or not it's on, select star from sys.change tracking databases, where the database ID equals the database ID of the one that we want to turn it on for. So this is how I can programmatically script that. And then once I've got that, the database piece of it scripted, I can go table by table and enable that. In this case, I'm only turning it on for a single table, for my employees table. So enable change tracking, and then with track columns updated equals on. I could set that to off, or just not specify that value, and it would default to not track those columns that were changed. All right, so that's how to turn it on the database side. And on the table side, I want to scroll back up and show you one piece that I alluded to earlier, but I didn't fully flesh out yet. I'm creating a table. This is a custom table that I'm creating. I give it a name called change_tracking. You can call it whatever you want. This is the table where I'm storing that version number, and I'm storing it at the table level. So you can see that I'm creating that. I've got a schema called ETL. This doesn't come automatically with using change tracking. I created the schema. I'm also separately creating this table. I'm tracking the table name and the change tracking version. So the reason that I'm doing that is I might want to run two different loads at two different times. So I might want to load my fact tables separate from my dimension tables, and I want to see on a table by table basis what that change tracking version is. As I mentioned earlier, that change tracking version, that big int value, will be updated not once per table load, but once for any operation on a tracked table in any table in the database. So in this case, just to isolate my operations, to keep things individually executable, I like storing that not database-wide, but in my tracking table. I'm going to store it to be table specific as well. So turn it on in the database, turn it on in the table, and now I'll insert into my change tracking table the name of the table that we're tracking. So in this case, it's dbo.employees. And remember one of those functions that I told you about, change tracking current version. This will grab from my change tracking history whatever that current version is. In fact, if I run this code that has been commented out here, you'll see that right now the current version is 1178. So anything forward of that, so if I start making changes now, that will continue to increment that, and it will go up from there. It's important to remember that this number, this version number, is not necessarily row specific. So if I update 1,000,000 records, if it's a batch operation, that's not going to update it's not going to add 1,000,000 to that. It will update for every batch, for everything that SQL Server detects as a batch. If I have a fairly large load, it may update just one time. It may go from 1178 to 1179. So it's not necessarily row specific, but batch or operation specific. All right, so we've got that. We'll close out with that query. So we're going to do a couple of things. On the table that we were changing or tracking the changes on, I'm going to perform a couple of updates. I'm going to update and set my active flag to 0 where the employee type is T or terminated. We've got a few new people that we hired, so I'm going to add in a couple of new records here, and then I'm going to delete a handful of records from that table as well. So we'll go ahead and execute that. So I had 39,000 that we updated, I had 3 that we added, and then 9 that we deleted. So those were the changes. Now I'm going to jump over to my check script. So I'm going to do a couple of things here, and I wish I'd now added a couple of comments here, but I'll walk through what it looks like. So initially I'm setting up a big int variable. I'm calling it CT or change tracking version. This is going to be where we track for this table what that last change tracking version was. So you can see I'm selecting into that variable change tracking version from that custom table that I created, where the table name equals dbo.employees. So that will now be, this is the marker for the beginning point of my load. Wherever we ended the last load, this is now the starting point for the current load. Now it's as simple as selecting everything from the employees table. I'm actually using the change table function. Remember I told you that was the second function that you're going to use a lot. Change table in this case takes 2 parameters. It actually takes 3 parameters. The syntax is a little bit quirky, but here's how it works. Change table function, I want to get all the changes on the dbo.employees table since this version. So since the last version that we set up. And what we'll end up with there is an error. Let me go ahead and run the whole thing. All right, so these were the 39,032 records that were affected since the last time we performed an ETL operation, specifically since the last time we updated the value in this table, since we updated that change tracking version number in our custom tracking table. So, and if I go run that again, let me uncomment this piece. So you can see that I'm joining a function to a table. Effectively what I'm doing here is I'm joining the results from change table. So this is going to be all those primary keys, the operations, the version number, and things like that, and left join to the table we're actually tracking, I have to join on that primary key. So I mentioned that every track table in change tracking has to have a primary key. This is the reason for that, because change table is primary key centric. It tracks everything at the primary key level. So doing a left join on that, the reason I'm doing a left join and not an inner join is if I do an inner join, change table will return all the results, inserts, updates, and deletes. But if I do an inner join to the employees table, those records that were deleted are not there, so there's nothing to join to. That's why I'm doing a left join on this thing. If you don't care about deletes, inner join is fine. But in this case, I do care. I want to see those deletes for demonstration purposes, so I'll left that in there. And if we scroll, actually so I uncommented that, so we're getting not just the employee information, but all the change tracking metadata as well. So let me go ahead and run that query again. Now you can see our results set widened out just a bit. I'm going to scroll up there. This was everything from our original query. So this is the employees information. From this point forward, that's our change tracking information. And you can see I've got, among other things, I've got my change tracking version. I've got the operation that took place. Remember, we're tracking the columns that change. So I've got sys change columns. This is the column mask that I would use that function to determine on a column by column basis, was that column in my update set. Sys change context, I haven't quite figured out what that one, what exactly that one does, but employee ID, this is how we anchor back to the base table, employee ID to employee ID. And how that works is I'm going to scroll all the way down to the bottom. My deletes are where? Let's grab those deletes. There we are. So you can see the delete operations look vastly different than what the other ones look like. So I've got complete nulls all the way across in my base record. This is by design because I'm left joining to a record that doesn't exist, purposefully left joining to that record that doesn't exist. I've still got in my change tracking information, I've still got the employee ID. It will still show me that. It shows me that it was a delete operation under the sys change operation, but that base record is no longer there. So this can be useful specifically on a data warehouse load. If I want to expire or do a soft delete on a dimensional record, this is where that could be useful. So pull all this information in, do a soft delete. If that employee ID, if it was a delete operation, if this is the employee ID, don't delete the record, but go ahead and expire it or go ahead and set the active flag to 0 or whatever the structure looks like for you. This would allow you to do that. So those are the general mechanics of how you would use change tracking on a dimensional table. So this is what, in a realistic scenario, you would use that for. All we're doing on the previous query, I'm not doing anything with that data. I'm simply pulling back that result set and saying, show me all the records that have changed since our last version increment. So let's actually put that into play on something that would look like a data warehouse table. So I'm going to scroll down just a bit. I'm going to show you we're doing a merge statement here. And I'm merging my DW, my data warehouse.dememp table. So this is the one that we're writing to. I'm going to use a merge statement. I'll come back to that in a second. Up top, we're doing something similar to what we did previously, where I'm grabbing the current change tracking version. So this will be the last one, or the one that was the endpoint for the last load. I'm also setting up another integer, rather a big int value, CT version end. So this is the endpoint for the current load. As I mentioned earlier, if you're doing a batch operation like we are, this is not real time. This is going to be done in batch. I need to have not just a starting point, but an ending point as well. So I have a finite period where I know that my ETL ended on this process and no interim updates would have been affected by that. So as a little bit of insurance, I'm grabbing from my configuration table, that custom table that I mentioned. I'm grabbing the starting point. I'm also grabbing the ending point using change tracking current version. What's the version number right now? That's now my ending point for the remainder of this load. So what I'm going to do with that information is grab the last load for dim employees, or for the employees table rather. It's going to write that into the CT version big int value just like we did previously. Going to grab the current date, and this is going to be, so I'll use this in my merge statement. I'll show you why I'm using that in just a second. So at this point, I've got my starting point based on my configuration table, that custom configuration table. I also have my endpoint, which is whatever that current version is as of right now, or more specifically, whatever that current version is when this line of the script runs. That'll be our endpoint for the entire load at this point. I'm going to grab the current date for my insert operation. Now we do the merge. Again, you might use this on a fact table. This is going to be more common on a dimensional table than a fact table. So I'm going to merge into that table using, here's the query that we're using. Joining, just like we did previously, joining change table, left join to employees on employee ID equals employee ID, where the syschange version is less than or equal to the version end. Again, our fixed ending point that we had up here previously. So that'll be our ending point, and I'm filtering only by insert and update operations. You don't necessarily have to do this, but for this merge statement, we're not doing anything whatsoever with deletes. If something were to have been deleted on the source side, we're not making any provision for that. I could separately have some logic that would say if it's a delete, like I mentioned earlier, do a soft delete, do an expiration, or however you handle that. But this makes it easy to quickly identify from the source side what that operation was. Joining together that set of data on my target based on the employee ID, and at this point, we just revert back to a regular old merge statement. When matched and not first name equals first name, last name equals last name, and so on, then perform an update. So this is simply a type 1 slowly changing dimension where I'm not retaining history. I'm simply doing the update. I could make this more complicated, certainly, and do a type 2, a type 3, or any of the other types based on insert, update, and delete values. But just to keep it simple for demonstration, we're only doing a type 1. So if that record is found, it doesn't match, then perform an update. When not matched, then I'm simply inserting into my data warehouse table those values from the source side. And then lastly, so it looks like I fat-fingered my update and took off some code. So what I would have needed to do is, I've got a missing piece of code here that I must have inadvertently deleted. After that merge statement, and this is the most critical part, after that merge statement, I need to go back and update my change tracking table, that custom table where we're tracking the version number, to make sure that we don't rerun that same load all over again. So if I run that now, 39,023 records were updated. So what I need to do now is, we're running a little short on time, otherwise I'd write the code live. What I need to go back and do now is update that configuration table to bear the new number specifically. That would bear this number. The ending version for this load will be the starting version for the next load. So again, it'll leapfrog itself every time. So the beginning becomes the end and so on. Or rather, the ending becomes the beginning for the next one and so on. So that's at a high level how to do a dimensional load. Let's talk briefly about how to do a fact load in the same realm. So I've got a separate script for this. We've already got our change tracking table. I'm not going to recreate that. No, we don't want to drop employees table. Let me grab the right script here. There we go. So I'm going to drop and recreate my pay history table. So this is my my table not in the data warehouse necessarily. This is on my OLTP side. So insert into that table where the pay date is less than 11/15/2016. We just dropped and recreated the table. Now I need to enable change tracking on that table. In fact, let me turn off column tracking because I don't care about that on this one. I'm not looking at the individual columns. I'm only looking at row by row. Was that row changed? So we'll turn that on. I'm going to delete from my configuration table if a record exists for pay history, grab whatever the current version of change tracking. So this is my starting point for my load. And then finally, I'm going to truncate my fact table just so we have a clean starting point for that. So let that run. We're going to make some changes. I'm going to insert into my pay history table from my source table further upstream for today's pay date. So those are my records, my pay records for today, 117,000 new pay records for today. Now, what does that look like? Same thing that we saw earlier. I'm grabbing the current version from my configuration table, changing the name of the table instead of employees. Now it's pay history. And now we can see those changes when I run the operation down below. Everything at this point is all an insert operation. So we didn't have any updates. We didn't have any deletes. Should have 117,000 rows in my coming back from my change table function. All of them will be inserts. And this is fairly typical of a fact table load because we're typically not doing an update or an expiration. We're typically doing just a plain old insert. So how that factors into a SQL Server load scenario looks something like this. Like we saw previously, the value that we start from, the value that we end at, again, using the change tracking current version table. Instead of doing a merge here, however, I'm simply doing a straight insert. So insert into my pay history table, select all the values from pay history where the sys change version is less than what we determined to be the ending version, again, grabbing our fixed endpoint previously in the script. So this is what I should have done previously. In fact, we could probably copy and paste this over. Once I've done that insert operation here, now I'm going to go back and update my configuration table. So now I need a finite endpoint where that information ended. So insert into my change tracking, or update my change tracking table, update that tracking version equals the ending version. The ending point of this load becomes the starting point of the next, where the table name equals dbo.payhistory. So I'm going to run that. I should see 117,000 rows of data were loaded, followed by my one row update on my configuration of my tracking table. Now if I run it again, because this last update did run, it updated ETL.change tracking for this table. If I run this again, I shouldn't see any updates, or rather any inserts in this insert statement. And that's exactly what we see, because change table would have returned 0 rows. It didn't have anything that was inserted, updated, or deleted. If I go back and reinsert here, so now if I run that again, now I'll have another 117,000 because those changes were after that version number that we just stamped in there. So now I've got 117,000. Now if I rerun it, because again, in that last step, I configured the ETL to only update those pieces that, or rather only touch those pieces that were updated since the last load. Now we'll get 0 rows affected by that. So that's how to handle on a fact load. Again, you will occasionally, if you deal a lot with data warehouses, regrettably, you'll have some scenarios that have to be, the fact loads actually have to be a slowly changing fact scenario, or slowly changing fact architecture. That will be the exception rather than the rule. But this kind of gives you an idea of using change tracking, how to do your incremental load. You can use the merge statement for that. We really didn't get into how to use other tools like integration services. Everything that I showed here could easily be used by integration services, by put it into a SQL Server agent job, or however you want to schedule that. But it is fairly simple to do that once you understand it. The syntax is a little bit quirky, again, especially if you're using the change table function. It requires the 3 parameters, tell you what kind of change you want to get changes instead of a specific version number. You want for this table name, and this is the version number. But once you get past the syntax issues, it's actually pretty easy to understand. It's a well-performing operation, and if you have the ability to change upstream, change your data source, this is by far my favorite way to go. Cool. So a couple of final thoughts. Change tracking, a very efficient, very fast way to handle that. It does use the version stamp as we went through exhaustively in the demo. You do have to have some control over making metadata changes in your database. But once you get it set up, it's fairly easy to implement, or it's fairly easy to maintain. The old records automatically fall off, assuming a default configuration after 2 days or whatever you set that up to be. It is very, very fast. It doesn't require manual updates. And if you need to rerun a load, if you're using that method that I mentioned earlier about having that configuration table to store the last version, that does take some of the burden off, and it does help to make that a little bit easier. I want to open it up for any questions. We've got about 10 minutes left or so. If we've got any questions, let me jump over to the question section here. Oh, great question. Someone asked, how does a temporal table compare? Is it a better solution or case-by-case scenario? Temporal tables, I think they're good, but they're different. So if you've not used temporal tables, they're new to 2016. and they will effectively do a system version of that row. If you've got full control over your source system, this can be an option. Right offhand, I don't think that temporal tables are anything other than an enterprise level feature. I could be wrong on that. I'm just now starting to experiment with temporal tables. I really can't speak to the accuracy or, more importantly, the performance of those. It does look like a compelling feature to possibly use, but to give you a long answer to your short question, it looks promising, but I haven't fully vetted that out yet. Good question. Where does change tracking store the PKs for the changed rows? The quick answer is I don't really know where it stores those. There's not a materialized table that you can select from. The short answer is the way to get to those is using the change table function, but as far as physically where those are stored, I really don't know. I haven't gone searching for that. And can we use a composite primary key? Absolutely. The difference in behavior there is you saw when I was joining the two tables together, the change table or the result set from change table back to the original table. Instead of joining on just employee ID, I would join on employee ID and location number, whatever makes up that primary key. But the short answer is yes, you can do a composite key, but it would have, instead of joining on one value, you join on all those values from that set. All right, that was the last question in the queue. I definitely appreciate your time and attention today. You can get in touch with me, tim@timmitchell.net. If you want to keep track of upcoming presentations and things like that, you can subscribe to my newsletter. Feel free to ping me if you have any questions. And again, I appreciate your time and attention today.